All right, so this is for biology, chapter 6, sections 1 and 2. This will be some review at the beginning about chemistry, which you've learned before, so hopefully you're familiar with the words, and this is just a refresher. If it's not, please listen closely and make sure you do the other activities that I ask you to do. So, atoms make up matter. Matter, all living things are composed of. So, atoms are the basic building blocks of living things. Atoms can be divided into what are called subatomic particles. These are your protons, neutrons, and electrons. And each of them has some kind of unique properties. Protons are positively charged, and they're located in the nucleus. Neutrons have no charge, located in the nucleus, and electrons have a negative charge, and they're located outside the nucleus. As you can see in this image, this is the protons and neutrons in the middle, and the red represents the electrons that are on the outside of the nucleus. When you think about chemistry, you probably think about the periodic table. The periodic table is composed of elements. Elements are pure substance that cannot be further broken down by physical or chemical means, and there's many different elements that are known, and each element is made up of atoms specific to that element. For example, carbon is made up of carbon atoms. Each element has a specific name, like carbon, and symbol, like a C for carbon. Here's the periodic table organized into columns, rows, which you probably have learned about. Each atom has an atomic, or each element has an atomic number at the top. Like so here, hydrogen has a 1 at the top. What that means is hydrogen has 1 proton. 1 proton. Protons are positively charged. It also tells you that hydrogen also has 1 electron because the number of protons and electrons in an atom or in an element are equal. Okay, so each atom has the same number of protons and electrons, positive, equal, negative. But sometimes the number of neutrons can vary. And when that happens, these atoms are called isotopes of one another. Here's a great example, carbon. Carbon 12, 13, and 14. These are all atoms of carbon. This one has 6 neutrons, and this one has 8. When that happens, isotopes can be radioactive. What that means is this carbon 14 is not stable. It's more stable at the carbon 12 form. So the nucleus will break apart, and while it's breaking apart to become more stable, it gives off radiation that can be detected. And if that isotope does that, it's called a radioactive isotope. Radioactive isotopes can be used in X-rays, or are used in X-rays to produce visualization, so that's a good thing. But excess radiation can lead to cancer, so that would be a bad thing. A compound. If you put 2 elements together in an equal ratio, it forms a compound. And compounds cannot be broken down by physical means into simpler compounds. But chemically it can break down. So physical is their word there, if you didn't miss that. There you go. Chemical bonds. Okay. So atoms in their outer shell. Okay, so we have the nucleus in the middle, right, with protons and neutrons in the middle. I know mine are backwards there. And we have these orbitals around. The first orbital can hold 2 electrons, okay? And the next orbital can hold 8. When that outer shell is full of electrons, 2 in some cases, but most of the time 8, it is happy. It is stable. I mean, it likes that. And it wants to be full. So Bonds are when atoms interact with each other to form stable outer shells. The subatomic particle responsible for forming chemical bonds is called an electron. And like I said, to become more stable, atoms will lose electrons, gain electrons, or share electrons to become stable. Okay, covalent bonds. Ooh, a little secret extra credit question embedded in here to make sure you're listening. If you can tell me which atoms do not share electrons, or come up to my desk and tell me which electrons do not form chemical bonds and why, I'll give you a point of extra credit. Which elements? Okay. So chemical bonds, there's different categories. The first type of chemical bond is called a covalent bond. A covalent bond is when electrons in the outer shell are shared. Here's a great example of a water molecule, oxygen and hydrogen on the side. These two electrons are being shared between oxygen and hydrogen. Notice that oxygen's outer shell has 8 and it's happy, and hydrogen has 2 in its innermost shell. It's happy. This is a covalent bond, the sharing of electrons. Ionic bonds are when electrons are either given away, gained, or lost. When an ion or atom gives up an electron, loses an electron, it becomes positive, thus called an ion. If it gains an electron, it becomes an ion as well, but except negatively charged, and they form together an ionic bond. So ionic bonds are formed as a result of ions. So here we have a great example, sodium and chlorine, both atoms, both no charge, but they're a perfect pair because sodium has 1 electron in its outer shell, chlorine has 7. So when sodium gives an electron to chlorine, it has a full outer shell of 8, and chlorine has a full outer shell of 8. Since sodium gave away an electron, it becomes positive. Since chlorine accepted an electron, it becomes negative. Positive and negative attract each other, ionic bond. Some atoms do this more easily than others, ionic bonds. And ionic compounds can dissolve in water. So they're not very common in living things. Chemical reactions are done all the time in living things. And they're a process which group of atoms go from the reactants, the starting products, to produce something. They're reorganized somehow. To reorganize them, bonds have to be broken or formed to do that. And there's different signs that a chemical reaction might take place. Maybe it gives off heat, produces a gas in the process. Here is an outline of what a chemical reaction will look like. The starting products are called the reactants on the left side. What you produce in a chemical reaction is called the products on the right side of the arrow. And the arrow represents the movement, how the chemical process proceeds. Chemical equations do need to be balanced, meaning the number of atoms on one side needs to equal the atoms on the other side, because matter cannot be created or destroyed. It can change forms, change different molecules, but this side number should equal this side. So if you count it out, which you should, the number of carbons on this side of the arrow should equal the number of carbons on the other side of the arrow. Every chemical reaction needs some sort of energy to begin. That energy is called the activation energy. Just think about it. It does take energy to think, right? Do you just sit here and be a blob? It does take energy to do that, right? To talk. That activation energy is the minimum amount of energy to produce products. Some reactions actually rarely happen in the body due to the high activation energy needed to start those reactions. Some reactions, chemical reactions, release energy when they happen, and those reactions are called exothermic. Some reactions do the opposite and absorb energy, or absorb heat, or I guess heat is a form of energy, and are called endothermic. So the different types. All living things are driven by chemical reactions. We do things because chemical reactions are happening in our body. So they're essential to living, to carrying on. So to make our bodies, living things, work more efficiently, to require less energy to do the things that we need to do, there are these things called catalysts. Catalyst is any substance that lowers the activation energy needed to start a chemical reaction. They don't affect the amount of product made, and they're not used up in a chemical reaction. Enzymes are a specific type of catalyst. They are proteins in living things, and they are biological catalysts that speed up the rate of chemical reactions. Most enzymes are very specific to one certain kind of reaction, and they can be recycled. So here is a chemical reaction that shows how an enzyme interacts with its reactants to produce products. The reactants in an enzyme reaction are called substrates. In this example, these are the orange blob and the green blob. The specific location where a substrate binds is called the active site on an enzyme. Boom. The last step of the chemical reaction is the production of the products. You can see that the enzyme looks exactly the same as it did at the beginning. So the enzyme, like any catalyst, can go do the same thing. Take these reactants to produce these products. A few factors impact how well enzymes work. They are pH, how acidic or basic the environment is, temperature, affect enzyme activity, and then the enzyme concentration. So how much enzyme you actually have in solution. Affect how well enzymes work. And I believe lights go out. That's the end.